Hello, everyone. I'm Dr. Sri Banerjee, epidemiologist, biostatistician, faculty member. And in this segment, I'm going to be going over how to conduct a t-test in SAS. Many people think that there are many myths that SAS you can only use by coding, but in some of the recent versions, like the one you're using right now, actually allows you to conduct a menu-driven SAS analysis. So there's a lot of different techniques, but I'm going to go over this, and I want you to kind of take note of how this is done. So the one thing that I want you to get accustomed to is taking a look at some of the menu items that are available. So folder shortcuts, not really something I use. Files also I don't really use, but my data is something under files is actually there are multiple folders, and I use these to try to import. So when I import, I usually just click on some area and then kind of import something from another area. So, like for instance, if you were to download a data set from the cloud onto your hard drive, then you can actually upload. But that's not the focus of this presentation of this session right now. Let's take a look here, the tasks and utilities. This is what you are most, um, this should be your focus. So um, take a look at all the data menus. So here are the tasks, and if you look at the data, there's multiple things here, but you're not really, here if you're trying to characterize each variable, then these are some of the menu items that you would use. But what we're interested in order to conduct a t-test is to go under statistics, and then under statistics you have something called t-test. So you can double click on that, and then basically what you want to do is search for a variable, search for a data set that you're going to be using for the statistical test. And of course, for you, there's multiple data sets that you can be using, but this is what I have. This is actually an enhanced data set that I've put together. So the question that I'll be posing today is that is there a difference in BMI for people that have cancer versus people that don't? So BMI is actually continuous variable. One place that you start when you're looking at a statistical test, you don't just run an analysis. You want to see the assumptions, and the assumptions are that one of the variables has to be categorical and one of the variables continuous. So when you're trying to put the first, of course, thing that you do is change from one sample to two sample, because this is actually independent samples t-test. So the next thing that you look at is what types of variables will go in here. And a lot of people, when they're learning this, they get confused about this because they think that the grouping variable is what you're trying to put in here. That's incorrect. So here's where you can put your continuous variable, and there's multiple continuous variables in this data set that I've put together. But let's look for a variable that might be appropriate for this analysis. And I'm looking through multiple variables. And here is the variable for BMI. Now, this is just a continuous variable run of the mill. So you go ahead and do that, and then take a look at the type of cancer. I have specific cancers that are available. So take a look at prostate cancer. So let's take a look at the t-test. Let's run a traditional t-test and see what this gives us. So you go in and take a look at the at the p-value. There's the assumptions that are included in here. So the QQ plot actually allows you to take a look at normality. Now, some of these are not things that should be considered normality, but that actually is. So we're looking for the p-value here, and the p-value that you determine is actually over here, and so well, this is the test for normality, but the p-value that you want to be interested in is over here. Um, so the p-value, of course, is um, there's a lot of tables that come out of this. So these are the methods that you can do a p-value with, and all of these show statistical significance. So the answer is basically that when you're looking at the connection between BMI and prostate cancer, then higher BMI is associated with the occurrence of prostate cancer, and that's something that you would anticipate and expect um, from your hypothesis. So in summary, this is how you would provide a menu-driven um, output here, and so this is what you do. If you have any questions, please let me know. I hope this has made some sense. Thank you for listening.